Throughout this section, with the exception of circles, we've been working with polygons. A triangle is a polygon. So is a parallelogram. So is a trapezoid. So is a rhombus. So is a kite. Any shape that is enclosed and made up of straight sides is a polygon. The key thing is that it's a regular polygon. Now, in case you've forgotten, a regular polygon is a polygon in which all of its sides are the same length and all of its angles are the same measure. In other words, a polygon that is both equilateral and equiangular. Now, when it comes to polygons, to find their area, a lot of it has to do with the fact that regular polygons can be inscribed within a circle. And once you've inscribed that polygon within a circle, you get a bunch of different measurements that are going to help us find the area as we go through. If we talk about a point equidistant from each vertex, vertexes are here. The point that's the same distance from all of them is the center of that polygon. Furthermore, that center of that polygon would actually also be the center of the circle in which the polygon is inscribed. It's the center of the circle and the polygon simultaneously. And that's important because the distance between that point then and the vertex, which would be a radius of the circle, is also known as a radius of a polygon. So from center to corner is a radius of the polygon. We also talk about the segment that goes from center to edge, specifically perpendicular to the edge. So right here it would be PQ for on this one. And that distance, that segment, it's known as the apothem. Apothem. I know, that one's a new one. Opossum. It sounds like a possum, yes, but it's apothem. So the radius would have been things like PM or PN. In all actuality, there's a radius here, 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 and here as well. And PQ would have been the apothem. There also would have been an apothem going from the center to the edge right here, center to edge here, center to edge here, center to edge, center to edge. And a key thing here is that we have this perpendicularity, and that's going to help us as we move through this section. Last but not least, angle formed by two radii that are connecting consecutive vertices of the polygon. This is a polygon's central angle. So in the picture, that would be angle MPN. Now, recognizing these different segments, these different features of the regular polygon is important for us to be able to recognize what measurements we have and what ones we need in order to find the area of said regular polygon. So, we're going to identify some things. First thing is the center point. What is the center of this polygon? F. Beautiful. A radius. Now there are multiple radii drawn in, and there's more that are not labeled. But can we name at least one radius? Yes. FB is 1. You could have also said FA, or technically FE, FD, and FC are also radii. What segment drawn in is the apothem? FG. Center to edge is the apothem. And it also wants the measure of the central angle. First off, what's the name of the central angle? There's technically multiple of them. There's only one drawn in. Not quite. EFA? BFA? Technically either of them would work. BFA. Now I want the measure of that. So the measure of angle BFA. Now I haven't taught you how to find this, but at the same time, I have taught you how to find this. I purposely drew this one so that it was inscribed in the circle on this first one. A central angle of a polygon is the same as the central angle of a circle. And since it is a regular polygon, all of my central angles are the same. How many central angles are there in this polygon?
5.
5. Why do you think there's 5 of them?
Because I count 5.
True, but if I didn't draw them all in, how would you have figured out there was 5 of them?
There's 5 points.
There's 5 vertices, there's 5 sides. It is a pentagon. There's 5 central angles. They're all the same. What do they have to add up to? 360. Because they're the central angles of a circle as well. 5 angles, all the same, add up to 360. How do I find an individual one of them? You need 360 divided by 5. Where the 5 came from the number of sides. Also the number of vertices. 360 divided by 5. If I can math right, is 72 degrees. Try out B on your own. What's the center?
P.
P. What's the radius?
PB and PA.
PB and PA are drawn in. Are there others technically in this picture?
Yeah.
PC, PD, PE, PF, PG, PH. Anything that goes from center to vertex. An apothem drawn in. PM. Center to edge is the apothem. How many sides does this shape have? 8. So what's the central angle?
45 degrees.
45 degrees because it's 360 divided by 8. What if I followed up these questions, and this one's referring to this diagram, and asked what is the measure of angle AFG? Split it in half. Because this is a regular polygon, that makes this triangle an isosceles triangle. And if you draw the altitude down an isosceles triangle, which what the apothem essentially is the altitude of this, yes, it creates two congruent little mini triangles right there. And their measure is half this. So, split it in half. The measure of angle AFG is therefore 36 degrees. Same idea here. What is the measure of angle MPE? Anyone? Yeah, it's still the 45 divided by 2 because it's still connecting a radius and an apothem right next to it. When you have a radius and an apothem next to one another, you create this little right triangle, and that little right triangle's angle that's at the center is half of the central angle, so 22.5 degrees. Now that can be helpful when we get into finding our area, which is what's coming up on the next page. What we're focusing in on, finding the area. Now you'll notice that I ask you to find the area before I even give you the formula. Because you don't technically need the formula. Because it's made up of a bunch of triangles, a bunch of congruent triangles. And you know how to find the area of a triangle. So when it comes to these, you can work with the area formula, or you can break it up into a bunch of congruent triangles. And I'm going to tell you right now that the reason the regular polygon area formula is what it is because of its relation to these triangles. So, right here, what is the name of this 6-sided polygon, by the way? Hexagon. Earlier we had a 5-sided one. What did we call? What was it? Pentagon. 8-sided. 3-sided. Triangle. 4-sided.
Square.
Technically, being a regular polygon would be a square, but generally a 4-sided polygon is more widely known as a quadrilateral. 5-sided was pentagon. 6-sided was hexagon. What's 7-sided? Nope. Heptagon. That's like we think it should be sep because that's how it works, but it's heptagon. 8-sided was octagon. 9-sided. Nonagon. 10-sided. Decagon. 11-sided.
Is that where they switch it to the number and then gone?
Nope, that's after 12. 11-sided is a hendecagon. 12-sided, dodecagon.
13.
And then once you get to 13, it's a 13gon. And a 14gon, and a 15gon, and a 16gon, etc. Okay, but anyway, back to our hexagon. Would you agree that the hexagon, the regular hexagon, has 6 congruent triangles. Sweet. Okay. I'm going to find the area of one of those triangles. Area of a triangle. What's the formula for that?
A equals 1/2 base times height.
1/2 base times height. Okay, so 1/2. What is the base of the triangle?
Well,
2.
Up top, I got a 2.
yeah.
Yeah. No,
If that's 2, it's a regular polygon. That means that one's 2, that one's 2, that one's 2, that one's 2, and that one's 2. So, base is 2. What's the height? 1.5. I know that that is the height because it is perpendicular to a base. 1/2 times 2 times 1.5 happens to be 1.5. That's the area of one of the triangles. How do I find the area of the hexagon?
times it by 6.
Multiply it by 6. Six times 1.5. 9 units. Feet squared. So when it comes to finding the area of a regular polygon, you can always break it up into triangles, but you don't necessarily have to, because the formula builds off of this. There's actually 2 formulas for the area of a regular polygon. So, we'll come back to this one. But we're going to break down and build out our formula. Area equals. Now, if I look at what I did, I look at this problem. Okay, where's my invisible sticky notes? I'm going to write things on the page that you should not write down, but I'm going to write them in invisible sticky notes because I want them in the recording. Otherwise, I'd typically write on the board. Okay, so let's break down what we did. We had the area of the triangle. The area of the triangle had the 1/2. That's still going to show up here. So the 1/2 is what it is. Then we had the base of the triangle. Now the base of the triangle, how would you describe what the base of the triangle is, but on the hexagon? The triangle's base is what of the hexagon?
1/2. 2 feet.
A side length. So that's a side length. The height of the triangle. What would you describe the height of the triangle in terms of the hexagon? Goes from center to edge. Nope.
An apothum.
It's an apothum. An apothum. And then with this 1/2 and that, we ended up multiplying that out, and then we multiplied it by this 6. How'd the 6 relate to the hexagon?
The hexagon has 6 sides.
It's the number of sides, and number of sides is given by n. So the formula for the area of a regular polygon is 1/2. Now they don't write it quite in the same order. They do A, S, N. A is the apothum. S is a side length. N is a number of sides. Now that's one formula. The other formula is 1/2 A times capital P. Sorry, I was writing off screen. What does capital P generally stand for on a shape? It's the perimeter of the shape. Because what got replaced was S times N. Side length times number of sides. Side length times number of sides is how you find the perimeter of a regular polygon. Technically, you can add up all the sides, but if all the sides are the same and the number of sides is the number of, well, sides, side length times number of sides is perimeter. Now, I'll be honest. This formula, the only time I ever use it is if I know P. Otherwise, I use the top one. Okay, so 1/2 ASN is the formula we have. We got this pentagon here, specifically a regular pentagon. That's the key thing. So area equals 1/2 ASN. Do I know the length of the apophyte?
Which one's the apophyte? It's the dotted line.
It's the dotted line, center to edge. Do I know it?
No.
No. We're going to come back to that one. Do I know the side length?
Yes.
Yes, it's 10. Do I know the number of sides?
Yes. Yeah.
5. It's a pentagon. Okay, I'm missing the apophthegm. If only there was a way to find it. Put a little X on it? Okay, I'll put an X there. Or I could put an A. Do you want the A or the X?
X.
Okay. What shape do we generally use to find missing lengths? A triangle, specifically a right triangle, because with right triangles, we can do things like trig or Pythagorean theorem. So I've got that right triangle right there that I'm going to zoom in on here. Here's what I know about this right triangle. The vertical length is the thing I'm solving for. But do I know other things? The hypotenuse is the radius. Do I know the radius? No. The horizontal side is part of the side length. But didn't we talk about earlier this little right triangle? And I talked about this little right triangle was congruent to this other little right triangle. When you draw the apophthegm in, it breaks it into two congruent triangles. And if the side length is 10, that means this length is 5. Side length divided by 2 will give you that length, that half length of a side. Okay. I need to either know the radius or an angle to make this work. I don't know the radius. We already established that. But haven't we talked about angles already? Maybe like a central angle?
Is that supposed to be 5 over 2 or is it?
It was supposed to be an S. Side length divided by 2. How do I find the central angle of a regular polygon? What do the central angles add up to?
360.
How many of them are there? 5, because technically it's divided by n. 360 divided by 5 is 72. Is the central angle inside this triangle directly? No. Half of it is. So I take that 72 and I divide it by 2, I get 36. Little note to self, divide by 2 to get the angle in the triangle. More specifically, to get the angle in the triangle that is next to the center. And that's key thing to look out for because sometimes these triangles are going to be on different locations. So in this case, is that the top or the bottom acute angle? The top, because this is what my triangle looks like. So 36 degrees goes there. Now I can do trig. Which side length's the opposite? 5. Because I already established the hypotenuse was the radius and that we don't know that, which means x is the adjacent, and SOHCAHTOA tells me we're going to use tangent of that 36 degrees equals, is it 5 over x or x over 5?
5 over x.
5 over x. When the variable is inside of that fraction, I always multiply by what? Denominator. Always the denominator. Because I want to get rid of the fraction. I multiply by x. Is x alone? No, so I divide by tangent of 36. X is whatever 5 divided by tangent of 36 is.
6.88.
6.88. What did x stand for? The height of the triangle, or in the polygon, that is the apothem. So the apothem is 6.88. So now I actually have the information to find the area. Depending upon what you're given, sometimes you're going to have to do some trigs to find some missing things. And in fact, with regular polygons, more often than not, are you going to have to do some trig. Area equals 1/2 times the apothem was the 6.88 times the side length was 10 times the number of sides was 5. $172?
Yeah.
172 what's?
172 inches squared.
Inches squared. Now we're going to chat about this next one, but then we're probably not going to do the full next one. We're going to move to the back and talk about some of those because each of these has a slightly different setup. This is a regular polygon. A regular what kind of polygon?
The one with 6 sides.
Hexagon. So it's still that 1/2 ASN. I don't care how many sides it has. If it's a regular polygon, this formula works. That includes if it's a square. You could do this formula for a square.
Whoa.
It's efficient if you know the apothem and the side length. But probably not because side length squared is the area of a square. You could do this formula for an equilateral triangle. That one can be efficient if you know the side length and the apothem because then you don't necessarily know the height. But, okay. Do we know the apothem?
Nah.
Mm-mm. Do we know the side length?
Yes.
7.5. Do we know the number of sides?
Yes.
Yeah.
Yeah, it's 6. So we would focus in on the right triangle to find it. There's my right triangle that was drawn in. The apothem in this one again is vertical. What else do we know about this triangle?
It's 3.75 down there.
Why is that 3.75?
7.5 divided by 2 is 3.75.
Side length divided by 2. That is one of the big things that people tend to forget, or when it's a decimal, it trips them up. So I just wanted to deal with that. You could also find this angle here. Remember, you do the central angle, 360 divided by number of sides, and then divide that by 2, and that'll give you the angle in the triangle. Top angle or bottom angle in this one? Top, because it's the one by the center. So pay attention to where your triangle is in the original picture. We are going to stop right there on this one because this one otherwise has the same setup as the previous one. I want to focus our time on the ones that have a slightly different setup, which is our final page.
Yay.
What shape?
Octagon.
Octagon. More specifically, it's going to be a
Regular octagon.
regular octagon. I'm not going to ask you to try to find the area of a non-regular polygon, other than, of course, like triangles, parallelograms, rhombi, kites, trapezoids. The ones that we already talked about. I'm not going to say octagon and make it irregular. Hard pass. Do we know the apothem?
Yeah. Sweet.
That's what we're given on this one. Do we know the side length? No. We have to find that. Do we know the number of sides? 8. Sometimes we're going to have different things going into this, and you're going to have to calculate them. Here's the thing, you're always going to focus in on that right triangle. But as you focus in on that right triangle, that sometimes messes with people a little bit because of some of the things you have to do to manipulate to get to the correct pieces. The right triangle is always going to connect an apothem and a radius right next to it. For some reason, they like to draw it down at the bottom of the shape more often than others, which is great and fine and dandy, but be careful if it's not drawn there on where the angle goes. I know that's 8. What am I looking for? Side length of the regular polygon. So in the triangle, I want the bottom. That, in technically, yes, you could call it the base. Now, be careful. That's from here to here. That's going to make a difference later. Exactly. Okay. Do I know the radius?
Yeah.
Yeah.
What's the radius?
8.
No, that's the apothem. Do I know the radius?
No.
No. What could I find? The angle. I start with the central angle. Central angle I always find by doing what again? 360 divided by 8, because it's divided by n. 360 divided by 8 is 45. Does that go in the triangle? 22.5 does, because then to get the angle in the triangle, I divide that by 2. Divide it in half. That a cute one or that a cute one? Top or bottom? Top. Is it always the top? It's often the top. It's not always the top. The reason it's the top is look at where your triangle is. It's always the one next to the center. It has to be next to the center. That's the opposite. That's the adjacent. We're still doing
Tangent.
tangent. More often than not, it is tangent. Not always, but more often than not. What? There's a... Okay. Tangent of 22.5 equals, is it 8 over x or x over 8?
X over 8.
x over 8. Opposite over adjacent. Multiply by 8 because that's the denominator. X is alone, which means I type 8 times tangent of 22.5 into my calculator. I find that x is 3.31.
Times by 2.
Why?
Because it's only 1/2 of a side length.
This is half of a side length. So I need to double it. I need to multiply it by 2. My side length is 6.62. So you have to be careful of that. Sometimes you're going to have things to get them in the triangle. Some things you get out of the triangle and double them. Specifically, it comes back to that side length. Once I have that, it's easy. I plug into my formula. Area is 1/2 times the apothem times the side length times the number of sides. (211.84). What are my units?
Inches squared.
Inches squared, because it is an area. There are generally 4 situations you're going to run across when it comes to working with these. The first situation is I give you the apothem and I give you the side length, and then you're just plugging things in. The second option is I'm giving you just the side length, in which you're having to solve for the apothem. I'm giving you the apothem, in which you have to solve for the side length. The last option, what is that? A radius. It's a regular pentagon. It's still that same formula. Radius doesn't go into the formula. Do I know the apothem? No.
Yeah, it's 10.
No, that's the
it's not.
radius. I don't know the apothem. Do I know a side length? No. Do I know a number of sides?
Yeah.
Okay, that I do know. You're never going to have to solve for the number of sides unless I'm giving you the area and the apothem and the side length and saying, figure out how many sides there are. Working backwards. Y'all can do that. I don't know the apothem. I don't know the side lengths. When I don't know something, the shape that we focus in on, the right triangle. I draw my apothem in next to my radius. I could have drawn it there or here. Either way works. Focus in on my right triangle. You figured out by now, I tend to draw it separately. That was terrible, but we're going to pretend I can draw. I don't know this. What's this going to help me find? Apothem or side length? Side length. Is that the side length?
Half of it.
It's half of it. I'm going to put an X here. What's this?
That's your apothem.
That is the apothem. So I'm going to use A on that one, because that is the full apothem. What else can I find? Central angle. Is the central angle directly in the triangle? No.
So it's
Half the central angle. But I can find the central angle by doing 360 divided by 5. 72. Divide that by 2.
6.
36. And that's the angle that goes in the triangle. On the left side or on the right side? On the right side, because it has to be by the center. I want to solve for both x and a because otherwise I can't do this. I'm going to do some trig. That's the opposite. That's the adjacent. This is the hypotenuse. Am I using tangent? No, tangent's a bad one to use. Tangent uses two unknowns. Don't do it. Are you going to solve for x or a first?
We can do x first.
Sure. If I solve for x first, which trig ratio am I doing?
Sine.
Remember to only try to solve for one variable at a time. Sine of 36 is x over 10 multiplied by my denominator. X will be alone. 10 times sine of 36, 5.88. X was not a side length or an apothem, but to get to a side length, this was half a side, so double it. 5.88 times 2. 11.76. If I want to solve for the last side, I could do trig or I can do Pythagorean theorem. I recommend trig because Pythagorean theorem would require a rounded side. This time we do cosine. And we'd multiply by 10. I get 8.09, which is my apothem. And then from there, y'all know what to do. So. These ones can be a bit of a process, just because there's a lot of little pieces. Rounded to the nearest hundredth, you should get 237.85 centimeters squared.